Okay, so on that note, I've also created a YouTube account. And that way, when I post videos, they can just stay up. I don't have to delete them because YouTube has, unlimited storage space. So next Saturday, we're doing homework. That's the 20th. I want to talk about the test. I got through grading it, and there's only one test that didn't have, that has some answers missing. So if you want to keep working on it, just let me know. That's okay. The first two problems were good. A few people forgot to solve for C, but it's, or had a mistake solving for C. That's okay. Mostly good work. For 3 and 4, I would say make sure that you know what functions on top and what functions on the bottom. And you can use like a graphing calculator like Desmos. And that would change the sign to positive or negative. So some people got the wrong sign based on what function you subtracted. Okay, so I made a mistake. I had a problem. It was a good problem, but then I put bounds on the problem. So number 6, there is a solution, but it's not a real solution. And I told you that we would have real numbers in this class as our values that we work with. So even if you, most people put a good answer, but I just gave credit for that problem because I felt like it was a bad question. Okay, 7 was good. 8 went well. So I did 9.
Sorry, I think I missed what you were saying. What question were you saying?
Number 6. Yeah.
Oh.
So the solution had imaginary numbers in it. Or it was like a complex solution. So I just gave, I gave everyone credit because I just felt like I should have picked better bounds. And I appreciate you working through the problem anyway. So I think the only thing to say is that on the last question, I saw a few cool trig identities, so that was fun to grade. So good job, everybody. What was the answer? Okay, I'll try writing it up. It would be I'm gonna kind of skip some steps to just kind of put a little skeleton of what went on. So we got to the integral of -1 to 2 w with a 7/2 w to the 3/2. Okay, so we had w to the 9/2 minus w 3, 4, 5. So it's okay when you put in 2, but when you put in this -1, you've got a square root of -1, which is I, and this is also going to have a square root of -1. So you've got a lot of, we'll put the next step. You've got a lot of imaginary, you have an imaginary number as the result. 2 times 2 to the 9/2. We could do a root and then the power. Or actually that would look, could have it outside or inside. Let's put it inside, just to read it nicely. Still put in 2. And always remember, you put in this first, and then subtract putting in that lower bound, the smaller number. All right, so 2 and 2. Actually, we're going to root and have a power 5 underneath that root. Oh, yeah, that's fine. Okay. All right. -1, so have a square root -1. And I'm going to put the 9, that power on the outside this time. 9, 2 bits. Square root -1, and a power of 5. All right, just a little bit more, but I would like to start doing some notes. Well, actually, I'm just going to leave it there. So you could simplify it further, but this overall is the answer, where the square root of -1 is equal to I, so it's a complex number. Maybe not the real number. Okay, but again, I think you guys did a good job on the test, and I will get your homework scores over into the gradebook so you can know that where you are in the class right now. Let's finish 7.1. Does anyone have any questions from the test? I can go over any of those problems if you want them on the board. I will also be in office hour later, so you can stop by and we can look at your test together if you are concerned about your grade. Okay, 7.1. So we're doing, what's this called? Integration by parts. And I want to do a few definite integrals. So we're going to integrate from 1 to e x x ln of x dx. Okay, I want to let u equal ln of x. And then dv will be x. Actually, I'm jumping into it. My note or my suggestion on how to do these problems is to find the indefinite integral, take that answer, and then instead of doing plus c, evaluate from 1 to e. Okay, so before we go. There are other ways to solve this problem, but I would say find this first. Then evaluate. x equals 1 to x equals e. Okay, so again, we're still going to let u equal ln of x. Actually, let's go drop this over. Okay, we're going to do this part x dx. Okay, this side, derivative, derivative of u with respect to x, and then get du equal to 1 over x dx. That side, integrate. So we'll have v equal to x squared over 2. And then that formula we looked at last time was u times v subtract the integral of v du. So we go here to here, and then over there. Okay. X squared over 2 times ln of x. Subtract the integral of x squared over 2 times 1 over x dx. Okay. I'm at x squared ln of x over 2 subtract 1/2 the integral of x dx. So this integral will give you x squared over 2 and then multiply with the 1/2. Okay, a little more, and then we'll evaluate from that lower bound to the upper bound. Cool. Okay, so we're going to do the problem we started with. We went from 1 to e. Okay, all of this, we'll just write all of this again with that evaluation symbol. So we're not going to add c since we're going to actually find this definite integral. So put in e and then subtract, putting in 1 and then simplify. Okay, first part. e squared ln of e. Divide by 2. Subtract e squared over 4. Oh, actually, just minus plugging in 1. So 1 squared ln of 1 over 2. Minus, this will actually be organized, minus 1 squared over 4. Cool. Ln of e is going to be 1, and ln of 1 is equal to 0. E squared over 2, subtract e squared over 4, subtract 0, add 1/4. Let's get a common denominator. We're almost done. E squared over 4 plus 1/4. Make sure. One more example kind of like this, where we do a definite integral. Okay, this one. We're going to integrate from 0 to 1 y over e to the 2y dy. We're going to let, oh, actually, we're going to do the side note. So my suggestion is to find the indefinite integral and then use that answer and evaluate from that lower bound to the upper bound. Find this. Is this definite? Whatever. I think it's with an I. All right, so doing this integral by parts. U will be the function that gets easier with taking a derivative, or that's going to kind of reduce or simplify. So use y. And dv will equal e to the negative 2y dy. So this side will do the derivative. Du will equal 1 times dy. So du equals 1 dy. This will have a u sub in it, and you'll have v equal to negative 1/2 e to the negative 2y. then we go cross multiply u with v, and then do the subtract the integral of v du. So negative y e to the negative 2y over 2. Let's start here. Okay, this and this. And we subtract, we can just write it. We're going to just end up adding, but subtract this integral with this negative number. dy. Okay, one more time, just check it. This with this, okay, minus this, the integral of that with that. Let's do I don't want to mess up my signs, so let's just do the positive sign, and then we'll do the integral. So for that one, we'll have another u sub and get this, actually, this multiplied with 1/2, a negative 1/2, and then you also have that half, that 1/2 right there. So copy that first term, and then we'll work through the next term. Okay, so we're subtracting e to the negative 2y over 4. And then we use that part, we use this solution, like instead of adding c, we're going to take this and evaluate from, what was it, 0 to 1. Okay. So negative over 2. Subtract e to the negative 2y over 4. Okay, so I've written what we got down here. Negative y, e to the negative 2y over 2 minus e to the negative 2y over 4. Evaluate from 0 to 1. So you put in 1 through everything. Subtract putting in 0 through everything. And simplify. Negative e to the negative 2 over 2. Minus, and put in 1 here, minus e to the negative 2 over 4. Take away. The 0 goes there. 0 times anything is a 0. Yeah, it's going to be fine. And then minus e to the 0 over 4. e to the 0 is 1. And I think I'll get a common denominator right there. And where was it? Cool. -3 with this together. -3 e to the -2 over 4 plus 1/4. Cool. I have one more example, but also kind of trick to talk about. And that'll be it for this section. Looks good. So we're going to use this. It's a shortcut for polynomials. And integration by parts. The example is to integrate x to the 4th e to the x dx. So you pick the function that would get simple or simplified as you do the derivative. We'll choose x to the 4th, and that will be your dv. But instead of doing work each time, we'll have it all organized in a table. U will equal x to the 4th. dv is equal to e to the x. Or actually, and then we start with x to the 4th as your first one. E to the x over here. And this is easy. We integrate here and get e to the x. Derivative on that side, so 3x cubed. Okay, then we do parts again, but this is just organized scratch work. So integrate here, that would be e to the x. Derivative on that side, so 9x squared. Actually, a mistake has happened. That would be a 4. That's going to be a 12. Cool, that's better. And next one, 24 times x. This integral is e to the x. You keep going till you get to 0. Right. Derivative would give you 24. Integrate, give e to the x. Derivative, we have 0. And that's e to the x. So you get to 0 and you're done. So you would have had u times v. That's positive, just that number times that number. Yikes. Sorry. Apologize. Okay. And you would subtract, so back to this u times v subtracts the integral from here to here. And then you would, let's see, how do I explain? So I'm positive. And you subtract the integral of what we call v du. And then you do by parts again. And so you're going to have this being positive. Maybe we'll do an example after this one to help explain what I'm, the larger example going on. Minus, plus, that's it. Okay, so the integral we had before, that's right actually. It was x to the fourth e to the x dx. It'll equal x to the fourth times e to the x. Okay. Minus e to the x times 4x cubed. Plus e to the x times 12x squared. Okay. Subtract e to the x times 24x. And then add 24 e to the x. And then add c. Maybe I can explain it now that we've got the answer. So you would have done it by parts and gotten your u times v, and then subtract the integral of v du, which we kind of worked out in that table. Let us make one up. Let's try one more example.
So is that our
Oh yeah, and then that's the answer, all of that. Let's try just, have you, let's see. Check the stuff we've already done before we go further. I think we'll do x squared. I want to do x squared times e to the x. It's probably one of your homework problems, or will be on the homework, but that's okay. So instead of doing that shortcut, we'll just actually work through the problem to see, and maybe we'll do the shortcut as well to see that we get the same answer. Okay, u would equal x squared. dv is e to the x dx. Cool. du equal to 2x dx. And v equals e to the x. All right, our integral is equal to u times v, so x squared times e to the x. And then subtract the integral of v du, so e to the x times 2x dx. And by parts again, let's have u equal to 2x. Oh, actually, we'll jump to that later. Just go over here. dv is e to the x dx. u being e to the x. And this derivative would give you du equal to 2 dx. So x squared e to the x subtract u times v. Minus the integral v du. U is 2 dx. I think it would help to distribute that negative sign. And now we actually can do this integral right here. And it might be done. So plus this integral, the integral of, it's 2 times the integral of e to the x, so 2 times e to the x. Plus c. All right, and then we'll do that table again to see if we get this answer. So u is x squared. And this is e to the x. Our derivative will give you 2x. And then integrate to get e to the x. Derivative will give you 2. And that's an integral. Answer is e to the x. Okay, so this integral would equal this times this as a positive number, this times this as a negative number. Oh, we're supposed to go till we got to 0. One more step here. Okay, so this derivative, now you're at 0. That integral, e to the x. And across, and the plus. So now we're going to use the shortcut to get this equal to x squared e to the x minus 2x e to the x plus 2e to the x plus c. So they match. We got the same solution. And I hope that helps explain the trick. So that would be the end of that section. We'll do 7.2 next time. And thanks for showing up to class, everyone. I will have these meetings posted to Canvas soon.